In this presentation, we will discuss the CFS test framework, a new tool developed to enable automated testing and verification of CFS-based flight software systems. At a high level, the CFS test framework, commonly referred to as CTF, loads the test scripts, which are written in JSON and contain the test metadata and instruction. CTF then interfaces with the relevant external systems, such as one or more CFS cores. CTF will then execute the test scripts against the selected test configuration, capturing and logging the test results in the process. CTF is written in Python and utilizes a Python-based plugin system to allow developers and custom projects to extend the functionality of CTF as needed. The architecture shown here describes the different components used within the CTF framework. At the input level, CTF receives test scripts, which are in JSON, configuration files, and additional inputs used by plugins to interact with other external systems. The CTF core contains the components that provide core functionality for the framework. This includes, for instance, the plugin manager that is in charge of loading and managing plugins for CTF. This plugin-based approach allows users to create their own plugins or use existing ones. The plugins have a well-defined interface to interact with the core CTF framework and other plugins. Some of the default plugins provided by CTF include the CFS plugin, the CCSDS plugin, and SSH and remote capabilities. Lastly, the CTF Editor provides a graphical user interface for users to edit and execute test scripts. The CTF framework utilizes configuration files written in the INI format. CTF will load the default config file unless a specific one is provided via command line argument. Providing the configuration file via command line argument is useful for when users want to run in a different environment or with a different configuration, such as in a CI environment or in a hardware-based configuration where the flight software is deployed to hardware. The INI file contains different sections for each component or plugin in CTF. For instance, there is a CTF core and logging section that allow users to define core functionality and where the logs should be maintained. Additionally, there are plugin-specific sections that define configuration values for each plugin. For instance, the CFS section allows you to define where your flight software is, whether or not to build the flight software, and other fields necessary for CTF to interact with the flight software. Note that the configuration fields can be extended with more fields as needed, which is useful as new plugins are created or existing plugins are modified. Now we'll take a look at the list of CTF plugins that are provided by default with the CTF framework. The CFS plugin, which is one of the CTF's primary plugins, provides CFS commanding and telemetry verification, typically through the CI and TO apps. Additionally, it configures and manages one or more CFS instances during the test run. These instances can be running either locally on the same machine as CTF or remotely. The CCSDS plugin provides the functionality needed for defining and managing CCSDS header types and the message structure definitions. The plugin will read the CCSDS message definitions on startup. Lastly, the SSH plugin provides the capabilities needed to interface with one or more remote systems over the SSH protocol. Note that the SSH plugin is used by the CFS plugin in configurations where a remote CFS instance is hosted and interacted with over SSH. CTF test scripts typically contain multiple test cases, which each contain CTF instructions. Each instruction is mapped by the CTF plugin manager to its respective plugin and executed. Here, we take a brief look at the instructions supported by the CFS plugin. The first instruction is the register CFS instance, which allows users to register multiple targets in test scripts that require interaction with multiple flight software targets. Note that the register instruction receives a name for the flight software and attempts to load the configuration for that named target from the configuration file. Additionally, there is the build CFS instruction, which allows users to build their flight software according to the build configuration defined in the configuration file. Once the flight software is built and started, the enable CFS output instruction will send the necessary command to enable TO output to the defined IP import in the configuration file. Next, we have the send CFS command, which can be used to send a CCSDS command packet to the selected flight software target. A variant of that instruction is the send invalid length command, which can be used to verify that the flight software reacts properly to off-nominal command sizes. The check telemetry instruction is used to verify a telemetry piece against an expected value. The check telemetry also has a continuous check mode, which allows that telemetry value to be continuously checked for all packets received by CTF. The check event message allows you to check that a certain event message was put out on the software bus, and supports formatted strings in addition to regular expressions. Lastly, the archive CFS artifacts instruction can be used to pull files from the target flight software that could have been generated during the flight software run. Note that all plugin instructions are documented in the CTF Framework documentation and repository. Here we take a look at some sample configuration parameters for the CFS plugin. The most commonly used parameters are the CFS build and run directory as well as the executable CTF should run. Additionally, users can specify fields such as the endianness of the target, whether or not to run in an embedded mode, the target IP, and the command and telemetry ports. The CTF editor, mentioned in an earlier slide, provides the graphical user interface for users to modify and execute test scripts. The editor is designed to be completely data-driven, meaning that new plugins and instructions that get added to the backend will be automatically recognized by the editor and supported. The editor provides a modern user experience, allowing users to drag and drop test instructions and providing autocomplete for MIDs, telemetry fields, and command arguments. We'll now present a brief demo that showcases some of the CTF capabilities. To begin with, we'll walk through the CTF installation and setup process. To begin using CTF, first clone the CTF framework from the NASA GitHub repository. Once cloned, users can navigate into the CTF directory and begin setting up their environment and dependencies. The Setup CTF Environment script is provided to make that easier. Sourcing the script will prompt you for the location to install the Anaconda environment. The default location is the user's home directory. Once the environment is set up and all dependencies are installed, it should be activated by default. In the future, you can source the Activate CTF environment in order to activate the environment and the necessary dependencies. Within the CTF repo, a sample CFS workspace is provided in order to test and evaluate the framework's capabilities. Navigating to the external directory in the CTF repository, we can extract the sample CFS workspace tar file to the user's home directory. A README is provided to walk users through the setup of the sample workspace and building and running the core. Navigating into the sample CFS workspace directory, which we just extracted in the previous step, we see a CFS project that we can build using make and make install. Once the project is built, we can navigate into the executable directory and run one of the two built executables. we can ensure that all CFS apps have been loaded and initialized correctly. We are now ready to run CTF test scripts. Going back into the terminal with the active CTF environment, we can run the CTF command to ensure that everything is installed correctly. CTF should complain about no test scripts being provided. Next, we'll run the CTF command and provide an argument with the path to a basic example script that will build and run the sample CFS workspace, send a couple of commands, verify telemetry, and shut everything down while logging the results. Here we see CTF loaded the script and the plugin manager began loading all the plugins for CTF. The CFS executable was started. The enable output command was sent and telemetry is being received. The test instructions are being executed. And finally, the core is shut down and a summary of the test result is reported on the screen. We have now executed a CTF test script using the CTF backend. We can also load the script environment using the CTF editor by running the CTF_editor command, which will build and run the editor front-end tool. Once the CTF editor is open, we can load a workspace file which tells the editor where the test scripts and configuration files are located. We can navigate to the sample CFS workspace directory, CTF tests, and open the editor workspace.json file. Once the workspace is loaded, you'll see the test scripts on the left pane of the editor. We'll open a sample test script that exercises the CFE ES instructions. These instructions are unique because they utilize functions defined in a separate CFE ES function file. For now, we treat each instruction as a separate block that takes in arguments as input. Some instructions only receive the expected command count and expected error count after these instructions are executed, while other more complex instructions have additional parameters for the command arguments, such as the command string and output file in this case. The script also handles starting up the CFS core and enabling CFS output. We can right-click the script file and choose Run either with a default config or a custom one. Here we'll choose default since our sample CFS workspace is set up in the appropriate directories. We see that the front end has started the CTF engine and began to build and run the flight software. Additionally, it will send the enable CFS output command followed by the ES no-op command. We can click the instructions to expand the details and gain insight about the data used for that instruction. The editor will show you a real-time status for each instruction and the overall test script. Note that multiple test scripts can be executed by selecting them from the left pane and clicking Run. Note that the CFS core is still running and the commands are being executed while telemetry is being verified. Once the test script is completed, the plugin manager will shut down all loaded plugins, which will in turn shut down the CFS instance. A good example to showcase CTF is writing a new test script. We can choose File, New Test Script to start an empty test script file. We can give our test a name. Here we'll provide example test as our name. We can also give it an owner, description, test setup, and requirements that that test verifies. We can also import functions by clicking the Add Import button, which will allow you to select a function's definition JSON file, where these functions can be utilized in the script. For now, we'll build a simple test case that starts the CFS instance. We can drag from the right pane the individual CTF test instructions into the test script canvas. After starting CFS, we will send the enable CFS output command, which is really a wrapper around the enable TO output command. The delay field here allows you to specify how long to wait before executing this instruction. Once we've enabled output, we can go ahead and send a CFS command by dragging the send CFS command instruction into the test case. Clicking the command will open the popover window that allows you to set the appropriate arguments. When the MID field is clicked, the CTF editor will auto-suggest all the different command MIDs that are defined in the CCSDS JSON definition files. For now, we will send an ES no-op command. We select the ES command MID, and once the command code field is selected, the auto-suggest once again will provide you with only the command codes for the ES app. We can choose the no-op command code, which will just send a no-op, incrementing the command counter on the flight software. Now we can drag the check to lem value block in order to verify that that command was successfully processed. Similarly to how send CFS command works, the telem value check requires an MID value, which is also auto-suggested based on the CCSDS definition files. We can check the ES housekeeping telemetry to make sure that the command counter field, which is also auto-suggested, is equal to 1. Remember to save your script often by clicking File, Save Test Script. Since this is the first time we're saving this test script, CTF Editor will prompt us with the location to save the script. Here we put it in the test scripts sample test suite directory and name it example test. You'll see the test script pop up in the left pane, and we can right click the script and choose run, again with the default config. This will build and start the flight software, send the enable output command, begin receiving telemetry, sending the no-op command and verifying that the command counter was in fact incremented. We can also intentionally provide an off nominal case where we can make this instruction fail by verifying that the command counter is 0. The instruction will run until the verification timeout is reached, and since the command counter will already be 1 at that point, we expect the instruction to fail. The editor will provide a graphical indicator for that failed instruction. In addition, the logs will print out the actual versus the expected value. The test failure will actually propagate all the way up to the test case and the test script. As mentioned earlier, the CTF framework was recently released on GitHub as an open source CFS tool and can be accessed in the following URL. We are currently working on certifying the framework as Class C software for verification and testing of flight software during the current fiscal year. We're identifying new capabilities and features that are needed and used by the CTF users, and we're currently in active development with several minor and major releases put out over the last year. We have an internal development repository hosted on the JSC GitLab. We're also supporting existing and new users, which include several teams on the Gateway program, in addition to the tool being used to certify the stock apps provided by CFS. We hope this was an informative and thorough introduction to the CTF framework, some of its capabilities, and how to install and use the framework. For more information, please refer to the CTF GitHub repository shown on the current slide.